Hello everybody. Today we'll talk about time weighting filters. So sound pressure levels or SPL are detected by measuring the pressure fluctuations in a medium through which sound waves are traveling. In most general cases the medium is air. And the common noise sources and environment can produce rapidly changing SPL. So it is necessary to dampen the sudden change offered by the noise so as to create a smooth changing SPL. And this process of dampening the sudden change is referred to as time weighting. So why is time weighting required? Where does the need arise from? So in the past, sound level meters had analog dials and needle that moves back and forth to display the current sound pressure level. Nowadays, we have digital sound level meters. So back in the day, when the noise levels change rapidly, the needle will also move back and forth rapidly. And when you're trying to make a measurement and you see the needles moving back and forth so quickly, you can't be sure what is the sound pressure level. So this proved difficult to interpret the SPL. To overcome this, known weights, actual physical weights, were applied to the needles so that the speed at which the needles move can be calculated and measurements can be made more reliably. In fact, these time weightings are still in use in today's digital sound level meters. If you think about it, the same problem would occur in digital sound level meters as well. That if there were no time weighting, the numbers would just fluctuate back and forth. And again, it'll prove difficult to make an appropriate reading. So there are different types of time weighting based on the different weights applied to the needles. So there is slow time weighting, fast time weighting, and impulse time weighting. We'll go through each of these types in greater detail. So slow time weighting offers 1 second response time. It means that it'll take 1 second for a sound level meter to react to the sudden changes in sound. The slow time weighting would ignore sudden changes in SPL and would give a smooth output. It is very useful for the environmental noise studies carried out for long durations. This smooth history can give a better indication of the average noise in the environment, and slow time weighting is noted by the capital letter S. So this is how the slow time weighting curve looks like. The blue dotted curve is the actual change in the sound pressure level in the environment, whereas the red curve represents the slow time weighting curve. As you can see here, the red curve slowly rises to that final sound pressure level that's in the environment. It takes 1 second to rise. So the next is the fast time weighting. The fast time weighting offers a 125 millisecond response time. It is pretty quick. It's like 1/8 of a second. And fast time weighting is more responsive to short and fast sounds, but not for impulsive sounds because we have a separate category for that. Fast time weighting does give a better resolution of the sound present, as it is more responsive to the sudden changes than slow time weighting. So if you want to capture, if that is more important for you to capture the sudden changes, you're better off using the fast time weighting, because if you use a slow time weighting, you might as well miss that. Fast time weighting is generally used for the basic acoustic analysis, and it is denoted by the capital letter F. So this is the graph. Again, the blue dot is the actual signal in the environment, and the fast time weighting shows that it rapidly increases to that level, within like 125 millisecond. Finally, we have the impulse time weighting. It offers even lower response time, which is 35 millisecond. It was designed to measure quick bursts such as impulsive or transient sounds, but currently it's no longer in use. Impulse time weighting, although it has a quick response, has a slow decay to mimic the perception by the human ear, and it is noted by the capital letter I. So this is how the curve looks like. As you can compare it with the fast time weighting, it's even sharper because it has a very slow response time, very little response time. So to conclude, time weightings are an accurate representations of the dynamic changes in sound pressure level, which are visualized with the sound level meter. And there are 3 types of weighting, namely slow, fast, and impulse, although the impulse is not in use currently. All right, thank you for watching this video. I hope you enjoyed it. Have a great day.